Hi, I'm Curtis Lassam. You can also find me on Twitter. I'm C. Lassam. I work at a company called Sauce Labs. I also make a comic about programming at cubedrone.com. This presentation is called Horse Drawing Tycoon, the world's best horse drawing simulator, probably. Or how I turned the world's dumbest JavaScript application into some paid time off from work. Or the unexpected virtue of ignorance. Yes, my presentation's full title is 31 words long. That's how you know you're going to get a lot of bang for your presentation buck. What other presenter is going to offer this sheer title density? Nobody, that's who. I'm going to start this off with a story. Van.js is a small meetup, local to Vancouver. The format is simple enough: 2 speakers, each delivering a presentation between 25 and 45 minutes long to a crowd of about 75 people, followed by an excursion to a local bar for drinks. One of the most difficult things about running this event, I'm told, is finding a bar willing to take a reservation for somewhere between 20 to 45 patrons who will probably drink about 1 beer each. I learned this from a friend of mine who runs the event, and we get to talking about video games. He got into iOS app development so that he could use contract app development to fund his true passion, indie game development. But as it turns out, iOS contract app development pays quite well. And for all but the most successful studios, iOS indie game development is roughly equivalent to shoveling big bags of money into a flaming pit. So my friend would prefer to prototype games in his spare time, and only devote company resources to developing them once they have a really good prototype. All of his ideas are really good, though. I took it upon myself to suggest some video game ideas that would never ever work. Like Breakout, but you play as the bricks. Because we were surrounded by software developers, somebody quickly volunteered the services of an indie game idea generator, which produces incredible ideas like a horror game where you ride horses with ninjas inside a gigantic terrarium. A student project where you procedurally generate equations and the game reacts differently to how you play it. Or an FPS where you stab researchers and you have the power to become famous at will. These ideas too were obviously much too good. I would play any of the games that it had described, but eventually it came to an idea so bad that nobody could ever want to play it. A Tycoon game where you draw horses indefinitely. That's the worst idea for a game that I had ever heard. I had to build it. And of course, in order to finish it before everybody forgot our bar conversation, I had to build it very quickly. Also, it didn't have to be very good. That affected a lot of design decisions. My Van.js companions had many questions. Questions like, how are you going to build it? Canvas? How are you going to make it a Tycoon game? Are people going to somehow upgrade their drawing? How do you know people are going to draw horses? Isn't this just going to end up being an obscenity drawing game? I would discover the answers to all of these questions. Although, spoiler alert, I did not at any point build a horse-recognizing artificial intelligence. So, before I go any further into this presentation, I have to tell you that this is an actual piece of software that exists. You can find it at horsedrawingtycoon.com. This is a horse that somebody drew with Horse Drawing Tycoon. The application has been running uninterrupted since I launched it. It's pretty stable. Bam, horse pun. And that brings us to Chapter 2, Canvas. The most interesting part of a horse drawing simulator would, of course, be the drawing part, which gives me an opportunity to talk about the HTML5 canvas element. The canvas tag allows you to create an element in the DOM that you can draw horses on. While I'm certain that there may be other uses for the canvas element, say video games or stuff involving graphics, I can't see how any non-horse drawing use of canvas is worth thinking about or even acknowledging. A canvas element exposes something called a rendering context to the page's JavaScript. A rendering context is an object that encapsulates all of the actions that you can perform on the canvas, the entire Canvas API. You can get a rendering context with code that looks like this. Here we're getting the canvas element from the document, and then calling getContext on that element. Then you can do stuff to the canvas element using the API defined by the rendering context. Here, for example, we're drawing a rectangle that is blue. Note that we're specifying a 2D context here. Canvas also has a 3D rendering API, although using it for our horse drawing application might be a bit out of scope. Now let's talk about the origin. If you're familiar with coordinate systems from math, you'll remember a grid where you have 0, 0 in the center, or bottom left, and different number pairs corresponding with different x and y coordinates on the grid. This 0, 0 point is called the origin. The reason that this is important is that Canvas's origin is in the top left rather than the bottom left. I mean, technically both of these origins are in the center of their spaces, but in math textbooks, y goes up, and in CSS and Canvas, y goes down. So looking at this line of code, for example, the arguments are x distance from origin, y distance from origin, and then the width and height of the rectangle. So 3 across, 4 down, with a width of 5 and a height of 6. That's how coordinates work in Canvas. The primary primitives to draw within Canvas are paths, rectangles, text, and bitmaps. The API calls focus heavily on drawing, coloring, erasing, rotating, scaling, transforming, animating, and compositing rectangles, paths, and text on a draw layer. This is the sort of tooling that lends itself really well to building a game engine, but for a stupid horse drawing application, it's a little bit complicated. The Create.js libraries are a collection of libraries for building rich context in JavaScript applications. There's Preload.js for dynamically loading assets, Sound.js for loading and playing sounds, Tween.js for animating, and Easel.js for working with the HTML5 canvas, which is what we want to do now. Easel.js contains convenience methods for a bunch of things in HTML5 canvas that are useful for games, like sprites, buttons, blurs, points, and strokes. The bitmap object, for example, is really useful for stamps. In fact, I don't have much to say about stamps at all, except that if you dynamically set the CSS cursor property and use a bitmap object in Canvas, poof, we have horse stamps. This is a low-res demo of horse stamps in action in my application. Look at that horse go. Yeah. Stamps are all well and good, but this isn't horse stamping Tycoon, this is horse drawing Tycoon, and we can use the stroke object to draw horses. When figuring out how to draw horses, the first thing I tried was just to draw a circle under the pen every time I detected a mouse move while the user was also left-clicking. The perhaps obvious problem with that is that the mouse can move much, much faster than the sample rate of the browser, so instead of getting smooth flowing lines, we just get dots everywhere. Okay, so the first thing I tried didn't work. We can connect these dots with lines to complete the drawing. This works pretty well, but fast movements will result in jagged drawings filled with hard edges. I remember that DeviantArt Miro simulated curves by simply connecting lines to many previous points instead of just a last line. It was a beautiful effect, but it wasn't really what I was going for. No, instead the technique that I ended up using was one that I found in a demo for Create.js. Between every 2 points I create a midpoint, and then when I reach the next point in the drawing, I create a quadratic curve from the last midpoint to the next point. Quadratic Bezier curves are way simpler than they sound. They're just 3-point curves. They go from one point to another, curving through a middle point. So here, we're just curving between the midpoint of the last line to the next point in our drawing. It ends up creating a nice, smooth line. So we've figured out drawing. That's good. Here we have a low-res demo of the tool in motion. It's low-res because I'm embedding it as an animated GIF. And here are some more horses that actual people have drawn using Horse Drawing Tycoon. We also have access to a cubic Bezier curve. The only difference between a cubic Bezier and a quadratic Bezier is that the cubic Bezier curve has one more control point. The quadratic curve is faster to compute. The cubic curve is more flexible and can be used to draw more shapes. We're not using a cubic Bezier curve in this project. I kind of just wanted to talk about it. One thing I talked about a bit earlier was dynamically setting the cursor property when I was making horse stamps. You can use the CSS cursor property to set the user's cursor to any image that's smaller than 128 by 128 pixels. For horse stamps, I would just set the CSS cursor to the same image as the stamp that was being stamped on the page. While the user was horse drawing, though, I built a little round cursor, making it transparent in the center and 1 pixel larger than the stroke that the user was painting with. Okay, so that's us. We're done with Canvas. We've finished. Which means it's time for me to show you even more horses. Some people were quite talented at horse drawing. This person seems to have a lot of trouble drawing a horse. Their next drawing supported this theory. That takes us to Chapter 3, Lucid.js. At the Van.js presentation, I had just attended a talk on Twitter's Flight, a componentiated event-driven framework. Flight looked interesting, and the concept of building my application as a collection of components that send and receive events really appealed to me. But for whatever reason, Flight itself wasn't the right framework for me. The reason was that months earlier, I had attended a talk on Lucid.js, which is pretty much the same thing, but I was paying way more attention during the Lucid.js presentation. So JavaScript also has its own baked-in event system, but I feel like it's important to maintain a separation between UI events like click and application events like clear canvas. Let's look at a simple Lucid.js event emitter. We can create an emitter to manage events, like this one here. Then we can bind a function to an event. Here we're binding a function to the super awesome event. Then we can call the function by emitting the super awesome event, passing any arguments we want to pass to the function. Lucid.js has a lot of features that are above and beyond a standard event emitter. You can have multiple emitters that selectively pipe specific events to one another. You can namespace events so that only specific listeners will receive those events. And you can even create meta listeners and listen on the very act of binding itself. Horse Drawing Tycoon comfortably ignores all of these features, but they're all potentially useful for larger applications. How is this better than just defining global functions and then calling them? Well, more than one function can be bound against an event. For example, the component that manages the canvas element could bind a function to the change color event, a function that changes the color of the current brushstroke. At the same time, the component that manages the cursor could also bind to that event and change the color of the cursor when it receives the change color event. Both of these components are responding separately to the change color event, and neither of these components needs to know about the other, or what the other component is doing with the event. The other benefit of an event stream is the events themselves become a stream of objects that you can manage. It's possible to serialize all events and store them for later, keeping a complete history of every action taken in your application. Or you could have a component that just listens for events that change the application state, and uses that to keep track of the application state using local storage. That same component could emit those events again when the application boots up. Now, if that sounds like a needlessly convoluted way to handle serialization and local storage in your application, I can assure you that it is, because that's how Horse Drawing Tycoon stores data. One of the problems with this sort of implementation is that components can tie whatever they want to an event. Replaying those events, we might only want to trigger some of these effects, but there's no really granular way to control them. This is one of those places where some of those more advanced features in Lucid.js would really come in handy, like namespacing, for example. If I were to rewrite the serialization of Horse Drawing Tycoon, I would probably not do it that way. It's quite a bit more complicated than I needed to make it. I still think events are awesome, though. And that ends our chapter on Lucid.js. But I have more horses to fill the gaps between chapters. Really cool horses. Which brings me to Chapter 4, Local Storage. When it comes to stashing things on the browser side, there are a few options that are well supported. WebSQL, which only works on Chrome and Safari. IndexedDB, which works in Firefox and Chrome and sort of works in Internet Explorer and Safari. And local storage, which works absolutely everywhere, but at the expense of being dumb as a rock. But actually, the simplicity of local storage is exactly what I'm looking for when I'm building such a simple application as Horse Drawing Tycoon. Let's look at the local storage API. You can write to local storage with setItem, and read from local storage with getItem. When you write to local storage, that data sticks around every time the user returns to your web page on the same browser. There are other objects, session storage and global storage. Session storage is like local storage, but even more temporary. It's cleared when the browser is closed or the user navigates away from your page. And global storage is like local storage, but it's older and deprecated and doesn't exist in a bunch of browsers anymore, and you shouldn't use it. Also, there are multiple ways to access local storage, using getItem and through standard object interfaces. Considering how the key I don't exist does not in fact exist, all three of these calls are going to fail. In this case, because the key doesn't exist, X is null, but Y and Z are undefined. So these different ways of accessing local storage data operate differently from one another. So that's a fun surprise. It's recommended that you use getItem and setItem on account of them working the most consistently across all browsers. Another important thing is that local storage can only deal in string data. So if you're dealing with anything that's not a string, you'll have to serialize and deserialize it, which is pretty easy with JSON stringify and JSON parse. There's one thing to consider when serializing data into strings: self-referential data structures. In JavaScript, a self-referential data structure, like the one I've defined right here, is unserializable. There are a few options for avoiding this kind of trouble. The first is to make it possible to serialize cycles using something like Douglas Crockford's cycle.js library. Your other option is just not to write code that has a cycle in it. Another thing to potentially concern yourself with is what happens when you run out of space in local storage. Quotas vary from browser to browser and are per domain. You might have 2.5 megabytes, you might have 5 megabytes, you might have unlimited space, and these are only the most common quotas. If you go over your quota, your browser will throw a quota exceeded error. I bet you're excited to hear how I built my application to cleverly avoid the problem of cyclical data structures and how I cleverly managed to keep my storage needs in check. I completely ignored those things. As it turns out, in an application as small as mine, it's easy not to write any cyclical data structures. And in an application as unpopular as mine, nobody's ever going to generate 2.5 megabytes of horses. So that's the chapter on local storage. Some of my horse artists were very literal, just writing the word horse. Quite a few of them, actually. Okay, so now we're going to talk about the horse rank algorithm. One feature of my application is that every horse drawing is run through a complicated artificial intelligence algorithm that ranks how horse-like every image is. Unfortunately, my horse ranking algorithm is an incredibly secret algorithm, and I'm not going to be able to tell you what it is. Oh, how did this slide get in here? I'd better move this presentation along. It's possible to use the getImageData function of a context to get the raw data that's being displayed on the screen at any given pixel. This function produces an object. This object has a data element that is simply a very, very, very long array containing a red, green, blue, and alpha information for every pixel. So each pixel takes 4 spaces in the array, and information is laid out 4 at a time in red, green, blue, and alpha for every pixel. Alpha being just a fancy graphics word for transparency. Once you get to the end of a row, the array continues with the next row. With that established, it's super easy to build a histogram of colors that the player used, and even display that histogram to the user. So that's the terrible secret of horse rank revealed. One user went in a clever direction and actually drew a horse drawing a tycoon. Another user drew me an ancient cave painting. So while we're talking about cool things that we can do with the entire canvas, let's talk about saving the user's horses, which is actually really easy with the toDataURL function. This function converts the whole canvas into a URL, but a URL that contains all of the data for the entire image, encoded in base 64. These strings are very, very long, but they contain all of the data of your entire image. These things are downright magic. You can just slap them into an image tag and bam, there's your image. Once the image is serialized like this, it's really, really easy to save. But it's also really easy to tweet. Which brings us to Chapter 7, secretly tweeting every single thing the user draws. If you'll navigate to twitter.com/infinitehorse, you'll see a stream of every single horse ever drawn with the application. I'd take you on a live tour, but if someone has drawn an obscene horse in the past 20 minutes, it could really shine an unpleasant light on this presentation. So the tweet function works about how you'd imagine it. When you finish a horse, the data is sent to a local service, which saves the ping data to a URL, and then tweets that URL. I'm going to leave the details of that server largely unexplored. This is a JavaScript conference, and I built the server machinery in Python of all things. The whole thing fits into about 160 lines and runs on Google App Engine for free. Because I hosted the tweet machinery on a different server than the one that I'm running Horse Drawing Tycoon on, I have to make a cross-origin request to save that tweet. Which brings us to our chapter on cores. As you know, making a request from one domain to another is forbidden in JavaScript. This is the same origin policy. There are a few ways to get around this policy. JSONP and cores. The first, JSONP, loads a script element into the page containing all of the details of its call in the URL. You're allowed to do this regardless of origin, so we load a script element that has our URL in it. In this example, we're visiting the server hearse.pix, or horse.pix without the O, with the data foo and the callback function cb. Then the server responds with a script that contains a callback function that returns any requested data to the application. In this example, we're calling back with the return data bar. This will call a function that you defined globally, returning control to your application with any data that you've requested. While it seems a little bit convoluted, jQuery will happily abstract most of these details away from you if you just tell it to make a JSONP request to a server. All you really need to do is make sure that your server properly returns a callback. There are some problems with this strategy, though. For one thing, it's only capable of sending GET requests. If you're a REST fanatic, the thought of using a GET request to set data on a server hurts you to the very core. On top of that, in order to fit our entire image, our URL would have to be over 50,000 characters long. While theoretically there's no limit on URL size, many standards-compliant servers and browsers start to choke after 2,000 characters, or 8,000 octets, and having a crazy long URL will make logging a nightmare. It just seems like a bad idea to use JSONP this way. Which takes us to the other strategy, cores. Cores, or cross-origin request sharing, resource sharing, shit, I misspelled it here. Cross-origin resource sharing is a relatively new feature, but it's now supported in all modern browsers. Cores is really simple. Before making a call to a URL, your browser will check to see if that URL returns a special access control allow origin header containing the domain that you are currently browsing from, or a wildcard which would allow anybody to use the resource from any script. Once the browser has checked that it is okay, it will gladly lift the barriers of the same origin policy for you. This, again, can be abstracted away with a jQuery option, so long as you spend 5 minutes making sure your server supports it. And that's it. That's all of the technical detail that I have for you. Now let's look at some horse drawings. Now you might imagine that the distribution of horse drawings might look like this, with 5% actual horse drawings and 95% obscene drawings. But in fact, after looking at a sample of 100 drawings, the actual numbers look a lot more like this. 11% incomprehensible scribbles, 23% recognizable horses, 1% obscene drawings, 30% some stamps, and 36% way too many stamps. It was actually really common for people to discover the stamp tool right away, and then draw me something that looks like this. Some horses were simplistic, minimalistic, elegant. Other horses were complicated and rich in detail. Some horses were magical. Some horses were fat. Some people had trouble drawing really compelling horses. I drew a horse. This one looks like an engineer drew a horse. I have many more interesting horses that I could show you. There are over 2,000 that have been posted since I built the app. But after all this talking, I'm feeling a little hoarse. Ah, another horse pun. Okay, so that's the presentation. I understand that I've thrown a lot of information up on these slides, so if you want to see anything after you've left, you can get the whole slide deck from curtis.lasem.net. Thanks for watching.